Hello student, I am Dr.A.K. Now I am going to discuss application of equilibrium constants. What are the uses of equilibrium constant I am going to discuss. Before going to discuss application of equilibrium constant, I want to brief it and just summarize, or you can tell I want to summarize the important feature of equilibrium constant. Okay, what are the important feature of equilibrium constant? First I will brief it and then I will come to the application. Application means uses, application of equilibrium constant. Then what are the, can say, this feature of equilibrium constant? Then there are 5 features. 5 important things are there, characteristics I will tell you. First feature, expression for equilibrium constant is applicable only when concentration of the reactants and products have attained constant value of equilibrium state or at equilibrium state. First characteristics or feature, expression for equilibrium constant is applicable only when concentrations of the reactants and products have attained constant value at equilibrium state. Means expression you can derive only at equilibrium state. Second, the value of equilibrium constant is independent of initial concentration of the reactant and products. Means it has, you can say, independent. The value of equilibrium constant is independent of initial concentration of reactant and products. It does not depend upon the value of initial value of reactant and product. Third, equilibrium constant is temperature dependent. Temperature is very, very important. Equilibrium constant will vary with temperature. Keep in mind. Equilibrium constant is temperature dependent, having one unique value for a particular reaction represented by a balanced equation at a given temperature. Okay. Equilibrium constant is related to temperature. It depends upon temperature. This is very, very important things. Fourth, the equilibrium constant for the reverse reaction is equal to the inverse of the equilibrium constant for the forward reaction. Again, this is the very important things. The equilibrium constant for the reverse reaction. Equilibrium constant may be for both, for forward reaction and for backward reaction, means reverse reaction. Then what will be the value of reverse reaction? Equilibrium constant value of reverse reaction will be inverse of forward. What was the for forward? Just reverse. Suppose if it was for forward reaction value was 5, for forward reaction Kc value was 5, then for the inverse reaction, for the reverse reaction it will be 1 upon 5 reverse. Okay, inverse what you are telling, what was the value of forward, just inverse of that. Give an example that if a Kc value was 5.03, then you can say for the reverse reaction Kc value will be 1 upon 5.03. Okay, this is fourth point I have told you. And Fifth point is again you can say very conceptual, that the equilibrium constant K for a reaction is related to the equilibrium constant of the corresponding reaction whose equation is obtained by multiplying or dividing the equation for the original reaction by a small integer. Okay. Here what you have to understand, that equilibrium constant K, suppose it is K for a reaction, is related to the equilibrium constant of the corresponding reaction whose equation is obtained by multiplying or dividing the equation for the original reaction by a small integer. Suppose for any reaction H2 plus I2, that is equal to 2HI. For this, if you can say its Kc value is 1, suppose, then if you multiply by whole things by 2, then its value will be 2 into 1. Okay, means you have multiplied by all by 2, then obviously Kc will be double. Okay, what was the original value? Double of that. If you are making it half, means H2, half mole H2, half mole I2, then obviously 2HI will be half, means 1 mole HI. Then whatever value was the original, their half, means Kc, suppose it was 1, then it will be 1 by 2, because you are divided by all by 2. Then obviously Kc value will be half of the original. If you are multiplying all by 3, then Kc value will be just triple, 3 times of the original. Suppose it was 1, then it will be 3 into 1. Okay, this is the fifth characteristics I have told you. Now I am going to tell the application of equilibrium constant. Then here there are two applications. First application is predicting the extent of reaction. Means you can find out what percentage of reaction can take place. Or taken place. That is the first application in knowing the extent of application, whether it is 50%, 30%, 60%, 99%, 100%. In predicting that, first application. And second application, that is second application is in predicting the direction of the reaction. Whether reaction will take place in forward direction or backward direction. Here you can predict by use of chemical equilibrium that reaction will be in forward direction or backward direction. Then in determining that direction also it is used. Then two applications are there. Then now understand one by one in details. Here the numerical value of the equilibrium constant for a reaction indicate the extent of the reaction. Numerical value of equilibrium constant. By that value you can tell for a reaction that numerical value of the this equilibrium constant for a reaction indicate the extent of the reaction. But it is important to note that an equilibrium constant does not give any information about the rate constant or rate of the reaction. No information. Okay, no information, only it will tell extent, how much reaction took place. It will not tell, no idea, it will not tell anything about the rate. at which the equilibrium is reached. Okay, the magnitude of Kc or Kp is directly proportional to the concentration of products. Always you keep in mind. The magnitude of Kc means value of Kc or Kp. Magnitude means value. The quantity you can tell. The magnitude of Kc or Kp is directly proportional to the concentration of products, as these appear in the numerator of equilibrium constant. Okay, equilibrium constant expression, and inversely proportional to the concentration of reactants. These appear in the denominator. Okay, this implies that the high value of K is a suggestive of high concentration of product and vice versa. Means here you are knowing that suppose Kc is equal to Kc you have written for the reaction A plus B, that is equal to C plus D. Then for this reaction Kc is equal to C into D divided by A into B, concentration of C into D divided by concentration of A into B. Then C and D is the product. Then directly proportional to the product. Kc value is directly proportional to the product, because product is upside, concentration of C into concentration of D, and inversely proportional to the reactant, because down you have written a molar concentration of A into molar concentration of B. It is in down. Hence Kc is inversely proportional to reactant. Okay, to the reactants, and directly proportional to the products. Okay, this is a very, very important point. Now again further you understand this Kc value or Kp value. I have told you that it is directly proportional to the concentration of products and inversely proportional to the concentration of reactants. Okay, this implies that a high value of K is suggestive of high concentration of product, and less value is there, high value. This expression, by this way you can understand that high value of K, if K is high, K is more, then product will be more. If K is less, product will be less. Okay, if K value is more means product, it will give more product, or it is giving more product. If K value is less, it means products will get less. A very, very important point. This I told you. K value is more, then product is more. K value is less, then product is less. Now just important point again I am telling you. Okay. If Kc if Kc is greater than 10 to the power 3 means 1000. If Kc is greater than 10 to the power 3 means 1000, then what will you conclude? If Kc is greater than 10 to the power 3, products predominates over the reactants, means product will be more than reactant. And just reverse way, if Kc is, or you can tell Kc is very large, if Kc is very large, the reaction proceeds nearly to the completion. If Kc value is very large, then it means product formed is more and reaction is completed, full 100% reaction. If Kc is very large, then reaction proceeds nearly to completion. Okay, now just to see examples I am telling you. The reaction of H2 and O2, the reaction of hydrogen gas and oxygen gas, at 500 K has a very large equilibrium constant. What its value? Then Kc value is 2.4 into 10 to the power 47. 10 to the power 47. This is the main figure. Okay. Then for H2 and O2 at 500 Kelvin, when both will react, that time equilibrium constant value is very large. That is the Kc value is equal to 2 into 4 into 10 to the power 47. That is important. More important, 10 to the power 47. 2.4 is not too much important, but 10 to the power 47, that is important. But here the exact value is 2.4 into 10 to the power 47 in case of H2 plus O2. Now, second example, H2 plus Cl2. It will form 2HCl, hydrogen chloride gas. Hydrogen chloride is acid also. When HCl will dissolve in water, then it will form acid, aqueous solution of HCl. Okay, HCl is actually gas. But when it dissolves at high pressure in water, then it forms hydrogen chloride acid, HCl acid. Then for this reaction, H2 gas plus Cl2 gas, it will form 2HCl, hydrogen chloride gas, at 300 Kelvin, and its Kc value is 4 into 10 to the power 31. 10 to the power 31. 31 is again more value. Okay. Now third example, H2 plus Br2. H2 gas, bromine is also actually gaseous form. Generally bromine exists in the liquid form, but here it is in a gaseous form. Okay, because reaction is going on. For the reaction they will come into the gaseous form, but bromine exists in the liquid form. Okay. Then H2 plus Br2, both are in gaseous state. It forms 2HBr at 300 K, and its Kc value is 5.4 into 10 to the power 18. 18. This is the Kc value. Okay. Then three example I give you. But here you have seen out of these three, H2 and O2 reaction will be fast, and more H2O will be formed. H2 plus O2, it will form water. Then it will form more water because its Kc value is high. 2 into 2.4 into 10 to the power 47. Second position is of HCl because its value is 10 to the power 31. 4 into 10 to the power 31. And third position is for HBr because its Kc value is 5.4 into 10 to the power 18. Okay, this example I have given. Then main things I told you, that if Kc is greater than 10 to the power 3, if Kc value is greater than 10 to the power 3, means 1000, then product will form. Okay, product will be more than reactant, forward reaction. And just other case, if Kc value is less than 10 to the power minus 3, minus means very less, 1 divided by 1000, 1 divided by 1000, then see that you are writing 10 to the power minus 3, then where 1000, where 1 upon 1000, 1 upon 1000 is very less. Then if Kc value is less than 10 to the power minus 3, then what you will conclude? Then if Kc is less than 10 to the power minus 3, reactants predominates. Reactants will be more, very large than product. Product will be very less. Reactants predominates. They will be more over products. Products will be very less, and reactant will be large. If Kc is very small, if K is less than 10 to the power minus 3 means Kc is very less. Kc is very less. If Kc is very small, the reaction proceeds rarely, means it will not proceed, or if proceed very slow, very slow. That's why reactant will be more and product will be very less. Okay. Now I am giving its example also. When what are the reaction whose value is very, Kc value is very less. That example I am going to tell you. First, decomposition of H2O into H2 and O2. Now suppose H2O is decomposing, then it will give H2 and O2, because from H2 and O2 H2O is formed. Then obviously when it will decompose, it will give H2 and O2. But for this reaction, now you can see, suppose this reaction is taking place at 500 Kelvin. The decomposition of H2O into H2 and O2 at 500 K has a very small equilibrium constant. Then what is its value? 10 to the power minus 48. minus 48 means exact value is 4.1 into 10 to the power minus 48. That's why when Kc value is so less, then obviously there will be no reaction or very less reaction. Only reactant will be there, product will be negligible, very less. Second example, N2 plus O2, it is giving 2NO, nitric oxide. N2 plus O2, it is giving a nitric oxide. Okay. Then now this reaction takes place at 298 Kelvin, and Kc value has again less, 10 to the power minus 31. Exact value is 4.8 into 10 to the power minus 31. It is very less. That's why that product will be negligible. Reactant will be more, means only N2 and O2 will be more, and NO will be very less, negligible. Okay, this example I have told you. The condition you have to keep in mind. Okay. And third case, if Kc is in the range of 10 to the power minus 3 to 10 to the power 3, between the two means between the 10 to the power minus 3 to 10 to the power plus 3. Plus 3 means only 3 you can tell, 10 to the power 3. Then what are its example? I am telling you. If Kc is in the range of 10 to the power minus 3 to 10 to the power 3, means plus 3, appreciable concentration of both reactant and product are present. It means at equilibrium, reactant and products both are present. Appreciable quantity means more quantity, both of reactant also and product also. Okay, if Kc is in the range of 10 to the power minus 3 to 10 to the power plus 3, appreciable concentration of both reactant and products are present. Now its example you can see. For the reaction of H2 and I2, for reaction H2 with I2, it gives 2Hi, you know already, H2 plus I2 plus 2Hi. For this reaction, what is the Kc value? Then Kc value is 57 and equilibrium temperature is 700 Kelvin. Okay, temperature is 700 Kelvin and both H2 and I2 are in equilibrium. Then that time Kc value is 57. Then 57 is between the 0.001 and 1000. It is coming in between that. Then its Kc value is only 57. Then neither it is you can say less than 0 nor this very high 57. Okay, 0.00001. It is more than 0.001 and less than 1000. Then 57. This is the example I have given. And second example I am giving you Also, you can say gas phase decomposition of N2O4. N2O4, when it will decompose, it will give NO2, 2NO2, N2O4. When it will decompose, 2NO2 it will give, 2NO2, nitrogen dioxide. Then in this case, what is the Kc value? Then Kc value is 4.64 into 10 to the power minus 3. It is very less at 25 degree, which is neither too small nor too large. Okay, it is there. Now you can't tell this is 10 to the power minus 3 is okay, it is less. Certainly it is less, but not very less, not very more, very high. Okay, not too small nor too large. 4.64 into 10 to the power minus 3. But product will be not too much and reactant will be also not too much, but both will be present. Okay, then this I have told you about this predicting the extent of reaction. Predicting the extent of reaction, how much product will form. How much product will form, that now you can understand. Okay, already I told you. Then you can brief that, hence equilibrium mixture contain, for this N2O4 it is converting to NO2. I am talking about that. The equilibrium mixture contains appreciable concentration of both N2O4 and NO2. Okay, this I have told about the these things, predicting the extent of reaction. Now come to the second application. Then second application is predicting the dissociation of the direction of the reaction, in which direction reaction will take place, whether in a forward direction or backward direction. Okay, that you have to find out. How will you come to know? By this Kc value will tell also that whether reaction will take place in forward direction or in backward direction. Then here, now these questions are asked. What I am discussing now, all questions are this examination it is asked. The equilibrium constant helps in predicting the direction in which a given reaction will proceed at any stage. Okay, at any stage in which direction reaction is going on. That you can understand by the use of, you can say, chemical equilibrium. Okay, now one term is there you should know, Q, capital Q. This Q and Kc, it looks same, but both are not the same. Here Q means it is just like Kc, only products, concentration of products divided by concentration of reactants. Okay, same. Kc is equal to products, concentration of products divided by concentration of reactant. Here also Q means same things, concentration of products divided by concentration of reactants. But what is the difference? Difference is that Kc is telling that at equilibrium, concentration of products divided by concentration of reactants, at equilibrium means at equilibrium position, what are the molar concentration of products and what are the molar concentration of reactants at equilibrium. But Q will tell other than equilibrium. Other than equilibrium means reaction is going on, but not necessary that they are in equilibrium. Maybe other time, any other time when equilibrium is not there. Then that time Kc value is called Q value when they are not in equilibrium. That is the difference. Okay, this Q is called reaction quotient. Reaction quotient. Reaction quotient. Q is called reaction quotient. Quotient. That is the difference. Kc is at equilibrium, but this is, and Q is other than equilibrium, not at equilibrium. The reaction quotient with molar concentration. Okay, same things, Q with molar concentration and Q partial, means Kp, Kc is applied for this also, but not at equilibrium, other than equilibrium situation. Okay, then this Q is defined in the same way as the equilibrium constant, except that the concentration in Q are not necessarily equilibrium values. Okay, as for example, now you can see for the reaction AA plus BB, that is equal to CC plus DD. Okay, for this Q is equal to same way C power C into D power D divided by A power A, B power B. This is the Q value, but this is not at equilibrium, not necessarily. Okay, not necessarily that they are at equilibrium, but Kc is 100% at equilibrium. Okay, but this is not granted, not these things that necessary. This is the Q I told you. Then now you should understand, if QC means just like Kc, QC you can tell. Just like Kc, QC you can tell. You can compare both. Then if QC is greater than Kc, then what will happen? If Qc is greater than Kc, the reaction will proceed in the direction of reactants, means reverse reaction. If Qc is greater than Kc, means if Kc is greater than Qc, Kc is more, then forward reaction, and reverse case, if Kc is less, then backward. Anyone you keep in mind. If Kc is greater than Qc, then it is in forward direction. Reaction is taking place at forward direction. If Kc is greater than Qc, and reverse case, if Kc is less than Qc, then backward direction, reverse reaction. This is the criteria you can understand. If Qc is greater than Kc, in the term of Kc better, if Kc is greater than Qc, then forward direction. If Kc is less than Qc, then you can tell backward direction. Okay, this is the important things I have told you. Means if Kc is more, then a reaction will take place, more product will be formed, direction of the product, and Kc is less than Qc, then reactant will be formed, and reaction will take place towards reactant. Okay, and if both are equal, Qc and Kc both are equal, then if Qc is equal to Kc, the reaction mixture is already at equilibrium. The reaction mixture is already at equilibrium. When both are equal, Qc is equal to Kc, it means the reaction mixture is already at equilibrium. Okay, when both are equal, then Kc and Qc both are equal, means they are in equilibrium. Okay, when the reaction mixture is already at equilibrium. Okay, then I will tell you these things. Value for you can say H2 plus I2, that is equal to 2Hi. Then for this for this you can say QC value for this reaction H2 square plus H2 square divided by H2 into I2. For this its value is, you can say, suppose its value is 8.0. Now in this case, this is simple, but they are given some value, H2 value, molar concentration of H2 and molar concentration of I2. Okay, that when it is at equilibrium, its value is 57. Already I told you, H2 and I2 both are in equilibrium, means they are giving HI and are in equilibrium. That time Kc value is 57 at 700 Kelvin. But any other values, suppose we have molar concentration H2, that is the 0.1 m, and I2 value is 0.2 m, and HI value is 0.4, means H2 0.1 m. Suppose it is given, suppose H2 is 0.1 m and I2 is 0.2 m and HI is 0.4. And that time Q value, that time you can't tell Kc value because they are not in equilibrium. Then that time Q value, if you will put the value HI square divided by H2 into I2, if you will put all this value, then it is coming 8. Then see, great difference is there. Its value is only 8. Then 8 means Q is less than Kc, means Kc is more than forward direction, means reaction is going on in forward direction. Correct? How quickly you can tell? By seeing the value you can tell comparative value. Kc value is more, means forward direction. Okay, if Kc value is less than Qc, then backward direction. This is important things I have told you. Okay, then this product is called right direction and reactant is called left to right, means forward direction, and this from right to left means towards reactant, reverse reaction. Reverse reaction is called, you can say, right to left, reverse reaction, and left to right means forward reaction towards product. Okay, then this I have told you about the, you can say, these things, prediction, application of equilibrium constant, equilibrium constant. Now I am telling about numericals based on, you can say, this chemical equilibrium, what I have discussed till date. On that basis, that 2-3 numericals are there. 4 numericals I will tell you, and which is important for your examination. Then question I am reading now. The value of, actually you have determined the Kc value. Now we will determine the Kp value. Or you can say, if you are knowing the Kc value, how will you know the Kp value? Okay, then, and in which direction reaction will take place? By seeing the value of Kc and Q, you can also determine. This is very easy. Now I am reading the question, the problem. Then problem is that the value of Kc for the reaction 2A that is equal to B plus C is 2 into 10 to the power minus 3. Means Kc value is very less. 2 into 10 to the power minus 3. Okay, for the reaction 2A is giving B plus C. Okay, and its Kc value is 2 into 10 to the power minus 3. At a given time, the composition of reaction mixture is molar concentration of A is equal to molar concentration of B, and B is equal to C. that is equal to 3 into 10 to the power minus 4 m. Means all molar concentration value they have given. For A also they have given A is equal to molar concentration of A is equal to molar concentration A is equal to molar concentration of B, and molar concentration of B is equal to molar concentration of C, and that is equal to 3 into 10 to the power minus 4 m. In which direction the reaction will proceed? This is the question. What I have discussed now on same concept you have to answer. Now two things they have given. First, Kc value they have given. You want Kc to tell these things, you require two things, Kc and Q. Then Kc value is 2 into 10 to the power minus 3. Okay. Then Q value you don't know, Qc value you don't know. Then for that purpose, they have given molar concentration of A, B, C all are equal, and they have given 3 into 10 to the power minus 4. Then what will you do? Now you are understanding. You calculate the Qc value same way, just like a Kc. Write the expression and put the value. You will get the Qc result. Qc value you will get. Then here for the given reaction, Qc expression for Qc, that is the product divided by reactant. Then here products are B and C. Then you write molar concentration of B into molar concentration of D, molar concentration of B into molar concentration of C, divided by reactant side it was 2A. 2A is giving B plus C. Then Qc will be B into C divided by A square, because 2A is there, A square. And now all concentrations are equal. All concentrations are equal, and its value is given, that is at 3 into 10 to the power minus 4 m. Then you put the value 3 into 10 to the power minus 4 upside right for B also, for C also 2 times. It means 3 into 10 to the power minus 4 power 2, and down again A square is there. A concentration again same things, 3 into 10 to the power minus 4, then A square you have to write because A square is there. Then it will automatically, all will cancel, only 1 will remain. Q value is 1. Q value you got, Qc value you got 1. Then now just simply you compare that Kc value is 2 into 10 to the power minus 3. 2 into 10 to the power minus 3, and here Qc value you got 1. Then see, 1 is far greater than 10 to the power minus 3. Means what question they have given? 2 into 10 to the power minus 3. That is very less value in comparison to 1. Then what will happen? Kc value is very less. It means reaction will be towards left, means reactant side, inverse reaction. Okay, as Kc value is far less than Q, so the reaction will proceed in the reverse reaction. See how interesting this question was there. Now other things I am telling you, last class already I have told you. Again one more numericals is there, that how will you can say calculate equilibrium concentration. Last class I told you how to calculate equilibrium concentration, not constant. Constant is Kc, equilibrium concentration. Then X, last class remember I told how to calculate X value. You have seen one question I given, that product was formed X mole, then at equilibrium position, and reactant in the beginning it was 0.1 mole. Then at equilibrium 0.1 minus X mole was remaining. At equilibrium it was given 0.1 mole was given, but at equilibrium x mole reacted and given the product x mole, two products x mole, then obviously 0.1 minus x mole will remain at equilibrium. Then 3 was there. Then total number of mole if you want to calculate, then you can add all. Then total number of mole at equilibrium. And last class I have discussed how to calculate the molar concentration. To get the molar concentration, to calculate the molar concentration, you have to write the expression for Kc of the given reaction. Whatever reaction is given, you write the Kc expression first of that reaction. Okay, this is the important things. Then same concept you will apply here. Same concept you will apply here. Okay, here main things you have to calculate number of moles at equilibrium of reactants and products. Of reactants, suppose two reactants are there, then for each reactant at equilibrium what is the molar concentration, and product, suppose two products are there, then their molar concentration you have to calculate. Okay, then for this main requirement is to write the expression. Then here in the term of Kc, in the term of Kp, also you can write the same expression in the term of Kp also you can write. For that time you will write pressure, partial pressure of gas, given gas. Reaction is there, na? H2 plus I2 plus 2Hi. Suppose all are in gas, and now value they have given in bar. Value they have given in bar. Okay. Then now Kp value you have to calculate, because value they have given in bar. Then you will calculate Kp, and expression will be same way, but pressure you will use. Pressure of H2, suppose H2 plus I2 is equal to 2Hi, as for example. Then pressure of Hi square divided by pressure of H2 into pressure of I2, that is equal to Kp. Okay, now this type of expression you have to write. If pressure they have given in the place of concentration, pressure they have given, then you have to calculate Kp. Then now I am reading the question. By the question you will understand. Actually there are 5 steps are there. 5 steps are there, part by part. Then easily you can, by numericals only you can understand. That's why I am reading the question. Okay, and because this type of question is very, very important for all universities examination, all medical, engineering, even for UPSC they will not ask. It is tough. That UPSC they are asking simple question. Okay, and practical type of question. But in UGC net question can be asked, same type of question. Okay, then try to understand, because it is based on concept. And question I am reading, 13.8 gram of N2O4 was placed in a 1 liter reaction vessel at 400 Kelvin and allowed to attain equilibrium. N2O4 is giving 2NO2. Question, this reaction is given. N2O4 sign of equilibrium, 2NO2 gas. Both are in gas. Question is, this reaction they have given. The total pressure at equilibrium was found to be 9.15 bar. Total pressure they have given, bar. Okay, calculate Kc, Kp and partial pressure at equilibrium. Calculate Kc, Kp and partial pressure at equilibrium. Okay, then it looks like that. How will you calculate Kp, Kc and partial pressure at equilibrium? You might be thinking like that it is difficult, but not that difficult. It is not difficult. First, you convert, first you can say balanced equation already they have given. It is given. Balanced equation is in question, it is given. Okay. Then now you can say first find out initial concentration. What initial concentration you have to write? Initial concentration. Okay. Then after that, third step, you can say equilibrium concentration. Kc expression you will write, a Kp expression, after that value you have to put. Then here first to understand what you have to do, this 13.8 gram they have given, not mole. They have given 13.8 gram. 13.8 gram they have given, not the mole. Then first to convert this 13.8 gram into mole. 13.8 gram means how many moles? Then 13.8 gram of N2O4. Then it is of N2O4. Then what is the molecular mass of N2O4? N2, if you will calculate, it will come 92. Nitrogen, you know that 14, its atomic mass is 14. Then 14 into 2, 28. O4, then oxygen is 16. Then 16 into 4, 64. If you add both, it will come 92. Then molecular mass is 92. Then mole, easily you can calculate mass divided by molecular mass. Mass divided by molecular mass. Then 13.5 gram divided by 92. 13.8 divided by 92. Then you will get 0.15. 0.15 mole you will get. Number of moles of 13.8 gram means 13.8 divided by 92, that is the 0.15 mole of the N2O4. Okay. This mole, in the beginning, this mole was there. Okay. Means 0.15 mole. Now you are knowing that at equilibrium, because this is in a vessel you have taken, 1 liter vessel. Total volume is 1 liter vessel, and temperature already is given, that is the 400 Kelvin, and they are in equilibrium. Okay. Then now you have to calculate, first you calculate Kp value. Then see, to calculate the Kp value, you have to, reaction is there na, NO2, pressure of NO2 power 2 divided by pressure of N2O4. This is the Kp expression. This is the expression for this Kp expression for this reaction N2O4. It is giving 2 NO2, means pressure of NO2 power 2. Okay, pressure of NO2 power 2 and divided by pressure of N2O4. This actually this is the expression for this reaction. Then now question arises, pressure, total pressure they have given 15. Total pressure is 9.15 bar. 9.15 bar they have given, and volume is 1 liter. Then how will you get the pressure? Total pressure they have given, but individual pressure is not there, not given. Individual pressure for N2O4 and NO2 not mentioned in question, not given. Then how will you get? Then now we have to think. Then here you have to remember that equation, recall the equation, PV is equal to nRT. PV is equal to nRT, ideal gasification. Then there, by use of this, you can calculate the pressure of, partial pressure of both you can calculate, N2O4 and NO2. Okay, then PV is equal to nRT, you know. Then P you want to calculate, volume is they have given 1 liter, P into V. nRT, N already you have calculated 0.15, already calculated na, 13.8 divided by 92, 0.15. Then P into V, P want to calculate, V is 1 liter, that is equal to N is equal to 0.15, R value is 0.083, 0.083 or 2 you can write, no problem, 0.083, that is the R value, and T value is given, that is a 400 Kelvin. Then you can calculate the P, pressure value will be 4.98 var. Okay, this you have calculated the distance, pressure you have calculated, pressure of the N2O4 you have calculated. The initial pressure was, now you are knowing initial pressure was 4.98. Initial pressure was 4.98. Okay, and initial pressure of NO2, automatically obviously it will be 0, because only in the beginning only reactant will be there, that reactant gives the product, hence obviously always product will be 0, always product will be 0. Then in the beginning partial pressure, now you calculated 4.98 var. After this putting the value, PV is equal to nRT, you put the all value and just solve it, then P value will become 4.98 bar. Then initial pressure is 4.98 var for N2O4, and for NO2 0, because in the beginning no product, only reactant will be there. But at equilibrium, what will be the pressure, that you have to calculate. Then actually product will be formed only from the reactant. Then suppose you don't know how much at equilibrium position what will be the product, that you don't know. Suppose it is X, okay, small x. Then now here only N2O4 will give the NO2, 1 mole is giving 2 mole NO2. The X mole, suppose this N2O4, X mole will give 2X. X mole of N2O4 will give 2X mole of NO2, 2X mole of NO2. According to the reaction, N2O4, that is the 2NO2. Means 1 mole is giving 2 mole. Then X mole will give 2X mole of NO2. Then reactant side, out of 4.98, in the sense now mole you can't tell. I have told you only just for the understanding purpose. Here it is in bar, pressure form, not the molarity form. Okay, it is the pressure form. Then 4.98 was there. Then X converted into 2X. Then at equilibrium now how much pressure will be there? Then 4.98 minus X for the N2O4 means reactant, and pressure will be 2X. Pressure will be 2X. Then now here total at equilibrium, what will be the total pressure? At equilibrium, what will be the total pressure? Then pressure of reactant, partial pressure of reactant plus partial pressure of product. That is the total pressure. Then partial pressure is 4.98 minus X plus 2X, that is for product. You add both, 4.98 minus X plus 2X, that is the total pressure at equilibrium. Then you add both, pressure of N2O4 plus pressure of NO2, partial pressure of N2O4 plus partial pressure of NO2 at equilibrium. at equilibrium, then means 4.98 minus x plus 2x. Then you will get 4.98 plus x, because minus x plus 2x. 1x will cancel out, only 1x will there. Means 4.98 plus x. That is the total pressure at equilibrium. But in question it is given. That total pressure is 9.15. 9.15. Then it is very easy to calculate. 4.98 plus x, that is equal to 9.15. 4.98 plus x, that is equal to 9.15. Total pressure is given. Then easily x you can calculate. Then x value will become 9.15 minus 4.98. That is, you can calculate 4.17 bar. Then now all thing is clear. X value now you are knowing. That is the 4.17. Means at equilibrium position, 2 into product was 2NO2, means 2 into x. Then 2 into x, and x you are knowing 4.17. Okay. Then now product you are knowing. For the reactant, x value are knowing, then 4.98 minus x was there. Then now we put there x value, that is the 4.17. Then now you are getting the N2O4 also. N2O4 pressure also you are getting 4.98 minus 4.17. Okay. Then it will give 0.81. Difference between the two, N2O4, the difference between the two, 4.98 minus x, that will x is equal to 4.17. Then it will give 0.81 var. That is the reactant. Reactant is 0.81 var, means N2O4. And product, that is the 2x, then 2 into 4.17, because x is 4.17. Then 2x means 2 into 4.17, means 8.34 var. Then now at equilibrium, pressure of both you are knowing. Pressure of N2O4 also you are knowing, and NO2 also you are knowing. Then just you put this value in expression Kp, that is the, you have written that NO2 power 2, partial pressure of NO2 power 2 divided by partial pressure of N2O4. Then here you put this value, partial pressure of NO2, that, and partial pressure of N2O4 down. Then you will get the result. Kp value now you got 85.87. After putting the value and after this doing solution, solve it. After solving, you will get 85.87 Kp value. Kp value now you are knowing. Then in the question they are asking Kp, Kc and molar concentrations. Then molar concentration already you have calculated, because x value calculated. Then molar concentration you got the value. Kc value, Kp value also you got 85.87. Then now Kc how will calculate? Then now remember, already I have derived the expression. You are knowing that relation Kp is equal to Kc into RT power delta N, means delta N number of moles of product minus number of moles of reactant. Then here delta N value, how will you come to know? Then reaction you can see N2O4, 1 mole N2O4 is giving 2 mole NO2. 2N means product minus reactant, 2 minus 1, that is the 1, means delta N is equal to 1. Then Kp value are knowing. Kp is equal to Kc into RT power delta N. The delta N is 1. Then now all value are knowing. Kp value you are already calculated 85.87 Kp. that is equal to Kc you want to calculate, R value 0.833 and T value is 400, power is only 1. Then now just you put all this value and calculate. After solving you will get Kc value is equal to 2.586. 2.586, that you can write as a 2.6. 2.6. Okay. Kp is equal to Kc. Kc you want to calculate, R value you are knowing, T value you are knowing. Power is delta n is 1. Hence all thing will be, RT value will be the same. Hence after putting all value you will get the, and after solving you will get Kc value. Means Kc is equal to Kp divided by RT. Kc is equal to Kp divided by RT. All value you put and you will get the result 2.6. One more question. Last question I am telling you, and you can understand, this is also easy. 3 mole of PCl5. Okay, next problem I am telling you, next question. 3 mole of PCl5 kept in 1 liter closed reaction vessel was allowed to attain equilibrium at 300 Kelvin. It is similar reaction. Calculate the composition of the mixture at equilibrium. Kc value is given 1.80. It is very easy. 3 mole of PCl5, initial concentration is 3 mole PCl5. PCl5 breaks into PCl3 plus Cl2, 1 mole each. Okay. Then 3 mole of PCl5 kept in 1 liter, volume is 1 liter. 1 liter closed reaction vessel was allowed to attain equilibrium at 380 Kelvin. Calculate composition of the mixture at equilibrium. Kc value is given. Kc is equal to 1.80. Okay. Then composition you have to calculate. Calculate the composition of the mixture. Composition of the mixture means same meaning. PCl5 will break and it will give PCl3 and Cl2. Then what is the concentration of PCl5, PCl3 and chlorine? Okay, all three concentration you want to know. Then you have to follow same things. But here is a Kc, hence easily you can calculate. Here they are asking Kc and already given in mole, hence this answer will be, it is easy, answer will be, you can say, answer easily you can calculate. Okay, very easily you can solve it. Then first you write the reaction. First, actually in this type of question, first you write the reaction. Okay, first step, reaction you write, balanced reaction. Then PCl5 will give PCl3 plus Cl2, means sign of equilibrium. PCl5 sign of equilibrium, PCl3 plus Cl2. Okay, first things you have written balanced equation. Now after that, initial concentration, what is that you have to write. The initial concentration, always first you write initial concentration, and then second step at equilibrium, total number of moles at equilibrium, that you can write. Okay, or at equilibrium condition, or at equilibrium position, what are the concentration of reactant and products you should calculate. And third things, expression you have to write, Kc expression or Kp expression. In this case, Kc expression. 3 step you have to write. After that you have to put the value and get the result. Then now same things we are doing here. PCl5 sign of equilibrium, PCl3 plus Cl2 you have to write, you have written. Then now initial concentration of PCl5 is 3 mole. Okay, and now you have to calculate composition. Let X let X mole per liter of PCl5 be dissociated. Suppose out of 3 mole, X mole dissociated per liter, because this is kept in per liter only, volume is 1 liter, means 3 mole per liter. 3 mole they have written in 1 liter vessel, means concentration is 3 mole per liter in the beginning, in initial concentration. Then at equilibrium, what will happen? Then this 3 liter, this 3 mole per liter concentration, that will dissociate and it will give PCl3 and Cl2. Then suppose X mole dissociated, X mole. Then at equilibrium X mole PCl3 and X mole Cl2 will form. Write there X. PCl, down the PCl3 write X and down the Cl2 X. And this side means PCl5 side, what will write? 3 minus X. 3 minus X mole is remaining. For reactant 3 at equilibrium, what is the remaining? 3 minus X mole. And products are X mole. Then these are the at equilibrium situation, condition. These are the concentration. Then you have to find the value of X. Then obviously all value will come to know. Then now expression, you put the value of Kc. Kc value, you know what will happen. Concentration of PCl5 into concentration of Cl2 divided by concentration of PCl5, that is the Kc. Kc is equal to molar concentration of PCl3 into molar concentration of Cl2 divided by molar concentration of PCl5. Now at equilibrium, what are the concentration? That value write. Then here in the place of PCl3 and Cl2, X into X, you have written divided by PCl5. Then PCl5 concentration is 3 minus X. That is equal to Kc. Means X square divided by 3 minus X, that is equal to Kc. Then Kc value is given. Kc value is in question it is given 1.8. Means 1.8 is equal to X square divided by 3 minus X. Then after solving this cross multiplication you do, then you will get quadratic equation. Ax square plus bx plus c, that is equal to 0. In this form you will get ax square plus bx plus c is equal to 0. You will get in this form. After the solution you will get in this form. Okay. Then now already you know that last class also I told you. Then how will you calculate? X is equal to minus b plus minus under root b square minus 4ac divided by 2a that is equal to X. This is the formula. To get the value of X. Minus b plus minus under root b square minus 4ac divided by 2a. Okay. Then by this way you will get the value of X. Okay. Because here you will get expression x square plus 1.8x minus 5.4 is equal to 0. Then here a is equal to 1, b is equal to 1.8, okay, and c is equal to 5.4. Then after putting all this value, the c is equal to 5.4 is there. Ax square plus bx plus c, and c value is minus 5.4, because in formula ax square plus bx plus c. But here in this question there you got expression x square plus 1.8x minus 5.4 equal to g, and c is equal to C is equal to minus 5.4. Then you will get x value after putting all the things in the formula. X value you will get 1.59. 1.59. X value got 1.59. Then see, then it means PCl5 and chlorine both are 1.59 and 1.59. And here reactant side, here reactant, that is the 3 minus x, means 3 minus 1.59. Then you will get this value 3 minus 1.59. Then you will get 1.41 m. Okay, 1.41 mole. 1.41 mole. Then now all composition you are knowing. Composition means here what are the concentration at equilibrium. Then now you have given 3-4 examples. I think it is clear in examination. This concept is sufficient. Only value will be different, and method will be the same. Method to solve the reaction, to solve the numericals will be the same. Now I am stopping only here. Next time again we will meet. Thank you.